So if we can write a rate, then we can make use of a proportional equation, and that just sets two rates equal to one another. Generally, I'm going to show you proportion equations with the same units on top on both sides of the proportion, and that way you can make sure you set it up properly and get the right answer, not something you weren't intending to find. So let's take a look at an example, and we're talking about gas again, since that's a place where we really use proportions quite frequently. How much gasoline should Katie need for a trip of 243 miles in her new car that's supposed to get 29 miles per gallon? Set up and use a proportional equation to find the answer. So to use a proportional equation, you may have other ways of solving this, and that's fine, but I want to show you how you can use proportional equations because it does come in handy to have a common way of looking at problem solving. So we'll look at her 29 miles per gallon, and so I think of it as 29 miles per 1 gallon, and then I want to set that equal to some number of miles per some number of gallons. Well, I know she wants to drive 243 miles, so I'll put the 243 miles on top for the numerator, and then the number of gallons for the denominator I don't know, so I'll just put an X gallons down here. Okay, now when I have this proportional equation set up, then I can start thinking, well, how would I solve something like this? And the first thing I think about is, well, let's just remove the units. We'll leave them there on the paper because they help when we get to the answer so we know what we found. But I'll just write it as 29 over 1 equals 243 over x, and then I will look at the two denominators and just multiply them together, so it'll be 1x or just x, and then I'll multiply that by both sides. Whatever those denominators are, if they're numbers, if they have variables, whatever, I'll just multiply the two together and then multiply it on both sides of my equation. And I really prefer that you use this method to solve your proportion equations, so I'm going to show it all through the semester. But the x's will reduce on this side because it's like an x over 1. And on the left side, I have 29 over 1, which is just 29, times that x, so I'll have 29x on the left and 243 on the right. Now I want the x by itself, so I'm going to look at what's being done to the x and try to undo it. 29 is being multiplied by the x, so I need to undo that. The opposite of multiply is divide, so I'll divide both sides by 29. And so 29 divided by itself, it's just like 2 divided by 2, you're going to get 1. So that left side is just a 1 times x, or x. And on the right hand side, I have a fraction, 243 over 29. And so again, I'll just use my calculator and divide it out. 243 divided by 29 equals, and I end up here with 8.3793, and it goes on. Now, really, I don't need all those decimal places in my answer. And when you work on Hawks, Hawks will tell you how many decimal places to leave. If I give you a worksheet and I don't ask you for a specific number of decimal places, you can go ahead and use 2. And that's kind of my default. So if I don't tell you otherwise, just use 2. And right there, I want to round to that position. So I look at the next digit. If it's 5 or higher, I'm going to bump that 7 up to an 8. If it's less than 5, like 4, 3, 2, 1, or a 0, I will leave it as a 7. So when you round, you only do it one time, and you look at the digit right after the position you want to round to. So on this one, since I have a 9 following the 7, it's going to be x equals 8.38. And I forgot what we were finding, so I'm coming back to my equation that we set up at the very beginning, and I see x is in terms of gallons. And so then I know when I found my x, that's the number of gallons. So my answer would be, write it out right here, Katie needs 8.38 gallons for her trip. There we go. So that's an example of a proportion equation.